Today, we're going to be shifting functions. It's really not a hard concept, but what's hard is the graphs get messy, so I tried a different tactic each hour. We're trying something different this hour. I think it's going to go the best this hour. Let's pray. Okay, so shifting for all functions works the same. We already know how to shift sine and cosine because shifting for all functions works the same. We know how shifts left and right work and how shifts up and down work. So just a reminder of if we have the parent function y equals x squared, parent function is the most basic non-shifted function. Right here I've drawn out the parent function. Now it was shifted right to, as we know how shifting works, we go opposite. So that would literally mean we take the parent function and we would go right 2 units for each point. Do you get what I'm saying, everybody? It's literally just shifted over right 2. I'm not going to draw perfectly. We already know that. Then also, right here is the parent function, the square root of x. Right here is the square root function. It was shifted up 4 units. We know how shifting works, so that would be taking it up 4, and then all those points are just shifted up 4 units. Everybody good? So shifting for sine and cosine works the same way. So here's what the equation of a shifted sine function looks like. Write this down somewhere. You're really not going to even really use your note packet very much today. You're going to want blank paper, though. So, y for notes. Yeah. Okay, so we have y is equal to sine of b theta minus h plus k. So last time we only have seen things like this. Y is equal to a sine of b theta, where a is the amplitude, b is the number of cycles from 0 to 2 pi. True? And then our period was 2 pi over b. So a is still the amplitude, which can also, if you think about it, think back to shifting other types of functions. If we had a 2 in front of a function, that would be like a stretch of 2, right? So I don't care if you call it amplitude of 2 or stretch of 2, because they are the same thing. So that could be considered a stretch or a compression, but really we'll just call it an amplitude. B is still the number of cycles from 0 to 2 pi, just like it was before. We still find our period by doing 2 pi divided by b, which is for sine 0 max, 0 min, 0. That's our period, the length of one cycle. There's one cycle. We'll still find that the same. The minus h is your shift left and right. You go opposite. That's also called a phase shift. So if they said there's a phase shift of pi halves, that was shifted left and right pi halves. Does that make sense, everybody? Phase shift is a left and right shift. So we go opposite just like with all other functions, and then if we add something on the outside of the function, it will just shift it up and down and the sign stays the same. So that is really the lesson. Now we just have to practice it. We already know how to do sine and cosine. One more thing though. B is not a transformation. B does not affect the transformation at all. B just changes your period. B only changes your period. Okay, here we go. So this is on, I want to point something out here. Look at these two. What do you see the difference? Yeah, 3 is inside the parentheses, and on the bottom one, 3 is factored out. Now here is what gets people, okay? There is a difference. Now here's why. To determine a shift left and right, you actually have to have a 1 in front of x. So right here, we're all good to go. Does everybody see? So in this one, we would be able to say our amplitude is 2. So everybody listening very closely, our amplitude's 2. Right here is b. So that does not affect the transformation, but it does affect your period. So we'd say our period is still 2 pi divided by b, so 2 pi thirds, everybody. Then our shift is, because that's a 1, we're good to go, we would say right pi. And then right here we would say up 4. Now up here, this is a problem. So does that make sense? That transformation is pretty straightforward. Up here, the problem is there's a 3 in front of x. So we need to factor that out. So if I factor something out, the catch is you can't just pull it out. You've got to pull it out and then divide each term by 3. So in this case, we would have to pull out a 3 first, and then we would get this. 2 sine, we pulled out a 3. Now left would be x minus pi thirds, actually, plus 4. So now we would say our amplitude is 2. Our period is still 2 pi over b, so 2 pi thirds. But now we're shifting right pi thirds actually. And this one's up 4. So just watch. Our class is always going to usually have 3 already factored out, good to go. But just keep that in mind, okay? Awesome. Because if I asked you to write an equation, you would need to have it on the outside of the parentheses. Okay, so let's answer these questions here. Honestly, these are so easy. I don't even think you should be writing them down. They're literally that easy. So just watch. Determine the shift from the parent function. Boom, there's our function. What's the shift? Right, 4. We go shift opposite with left and right, everybody. What's this one? Up 7, because that's added on the outside. There would be parentheses if it was grouped. This one would be left 2, down 5. Okay, good. All right. Now let's go backwards. This is a really good one. It says, given that the cosine function, transform it 2 units down and 5 units to the left. So we'd say y is equal to cosine of what? 5 units to the left. X plus 5 or theta plus 5, same thing. I don't care how you write it. Great point. Then what? Minus 2. Very good. Okay, let's do a sine one. It's been transformed. Pi units up and 3 units to the right. So we'd say sine of x minus 3 and then plus pi. And we're golden. Now notice it didn't say anything about our period. So let's pretend, like I said, well, the period is equal to, I don't know, 6 pi. Well, won't that change my b then? Because we know that period is equal to 2 pi over b. So if I'm given the period 6 pi, I would need to find b and put that in as well. Okay, so what I'm going to do now is on your homework, you're going to finish all the problems similar to this very quickly. 1 through 4, 11 through 15, go. So check your 14. It says a period is 3 pi. So you'd say, oh, my b must not be 1 anymore. So period is equal to 2 pi over b. Solve for b because period is 3 pi. So we times by b to both sides, divide by 3 pi. So our b is equal to 2/3. You say, okay, I've got to input that in. And then we'll go, okay, y is equal to, phase shift is left and right. This is positive, so then we're going to have, so we're going to have, let's see, sine of, we need a b. We need it factored out. So we need 2/3 on our outside, parentheses. Then it's already been factored out. That's not going to affect the shift left and right now. So then we're having x minus pi, and then it was vertical shift of down 5, and then our amplitude was less than 0, which means it's negative. Everybody good with that? Okay, do we have those finished pretty much? So a lot of you are asking the same questions right here. Because 3 was inside, we had to factor it out. So because 3 was already on the inside, we would factor it out. So then we would divide both by 3. So that's why it became minus pi thirds here. So, but right here, the 3 was already factored out. So this was straightforward right pi units. So we always want b already factored out. Here we go. My examples are not coming off your worksheet because there's barely any to do. So you're going to want to just take some notes on some blank paper. We are going to graph our own graphs. Okay, so with shifts up and down, it's actually really quite straightforward. So we're now just taking the original function and shifting them up and down. A lot of teachers, most teachers will make their students graph the parent function and then just shift it around. But I don't want us to necessarily have to draw a bunch of graphs. But sometimes I think it makes it a little harder. So we're going to kind of make a compromise here. Okay, so let's graph this. Y is equal to sine of x plus 3. So the first thing you do is list out your amplitude. Our amplitude is 1. Now remember, amplitude means distance from the midline. My midline is normally at 0 if it has not been shifted up and down. Our midline is usually at 0. The amplitude has been split over 0. But now we're shifting it up 3. Is everybody with me? Yes, our midline is the first thing we would draw in. Our midline is now at 3. So we go like this. We would draw in an XY chart here. The first thing we do before the amplitude is say this is now up at 1, 2, 3. At 3. Is everybody good? Now, from there, our amplitude is distance from the midline. I would draw in a dotted new secret midline for myself. So then from there, we're going to go up 1 unit, which is at 4, and then down 1 unit from the midline. Wouldn't that be at 2? Now, here's a trick I use. I will allow you to have a highlighter on the test if you want. I go to my amplitudes and highlight just because I know that's the max. That's the top of the amplitude. Does that make sense? So just so when I graph it, it's easier. So here was my amplitude. Here was my amplitude. Does everybody kind of see? Here's the x-axis, right? Here's the y-axis. And then there's my amplitude showing. Okay. Now from there, we would need to figure out our period. So our period is always 2 pi over b for sine and cosine. Isn't the b a 1? So our period's 2 pi over 1, which is 2 pi. So because there's no shift left and right, we're going to just go straight for it, the easiest way possible. We are still starting at 0 because there was no shift left and right. So we're going to do the same thing we did before. Over 1, 2, 3, 4. What would that put me at? 2 pi. I'm going to ask you on the test to graph 2 cycles. So we'd go over 1, 2, 3, 4 would be at 4 pi. Then fill in the rest of your tick marks. Now notice, this is the new x-axis, but I draw on the real x-axis my tick marks. Does that make sense, everybody? So then halfway between would be pi, would it not? So then halfway between 0 and pi is pi halves. So now think in distances, 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, 7 pi halves, 8 pi halves. Okay, there's 2 cycles. Now what we're going to do is say, okay, here is, look, the dotted x, and here is y. True? This is my new x, here's my new y. So right here is my new 0, 0. Is everybody seeing it? It used to be right there. Didn't it just shift up 3 units? Okay. So now let's go ahead and say, well, sine pattern is 0 max, 0 min, 0. True? So right here is the new 0. Does everybody see? So we shifted up. So 0. Next tick mark. I got to go to my next tick mark, go clear to the max. Next tick mark. 0. Next tick mark. Min. 0. Make sure your period ended at 2 pi. Yep. So I can now draw. Don't go above your amplitude. The amplitude still does highlights. We shouldn't come out of those highlighted. The highlights. Yes. 0. Next tick mark. Max. 0. Min. 0. And once again, we're good to go. Shifts up and down are really easy. Nothing changed besides we took it and shifted it up 3 units. Okay, let's do another one before lunch. Okay, let's go really quick since we only have 3 minutes, so we'll maybe just watch. So this is cosine that's been shifted down 1. You would list out your amplitude. Your amplitude is 1, and then we're shifting down 1. True? So you would go like this. Okay, I'm going to draw it pretty big, everybody. So down 1 unit. There's my new midline. My amplitude is 1. Isn't that up 1 and down 1? So at 0 and at -2. Is everybody with me? Then I'm going to highlight. This was the max and min, because that was the top and bottom of our amplitude. And then we'll fill in our tick marks. To do that, we need to know our period. Our period is 2 pi over b. b is 1. So our period's 2 pi. So on the x-axis, I'm going over, so starting at 0, going over 1, 2, 3, 4. Because the bell's going to ring, I'm only going to draw 1 cycle. So then this is at pi, pi halves, 3 pi halves. Now you'd say cosine. Cosine is this pattern. Max 0, min 0, max. True? We got to go to our new, right? Here's the y-axis. Here's the x-axis. Here's the 0. So max, 0, min, 0, max. Don't go above the highlight or below the highlight. Does everybody see? Was that easy? Yeah. Okay, cool. Yeah. Cool. So that's all before lunch. Fun. This is going to be the first time we shift left and right. Honestly, guys, this is going to be the easiest way. So just go with it, okay? So first of all, we will list out our amplitude. Now, we would list out our period. So our period is 2 pi over b. B is 1, so it's 2 pi. But then after that, we have to shift right pi half. So you're going to do, I'm not going to make you completely, well, yeah, just do what I'm about to do. So we're going to draw what's not our official graph. We're going to pretend like this has not happened yet. Let's pretend there was not a shift of right pi half. Then we will just graph it with this information. So our amplitude is up at 1, negative 1, true? And then over 1, 2, 3, 4 would be at 2 pi. So then right here would be at pi halves, then 3 pi halves. Now this is, this is going to make it easier. Okay, so isn't this cosine? So we'll go max, 0, min, 0, max. Now what we're going to do is we're going to go off to the side and list out what those x, y points without the shift are. So right here, let's list them out. X, y. So what's my first point? Over 0, up 1. True? Oh, this is going to be so much better. Over pi halves, up 0. Over pi down 1. Over 3 pi halves, up 0. And then over 2 pi, up 1. Okay, we're taking those x, y points, and now what we're doing is we're shifting them. So those are what are their parent function points, everybody. So now we're shifting them right pi halves. Isn't that just an x shift? Not going up or down. So you're going to go to your x values, and you're literally going to add, since it went right, add pi halves to each x point. So then we're going to list out our new x, y points. This is how I actually teach it in honors, and it's just so much easier for everybody. So what's 0 plus pi halves? So we're going to now be at pi halves up 1. Cross that out because we... wait, pi halves plus pi halves, you're right. It's pi up 0. Awesome. Pi plus pi halves is 1 plus a half is 3 halves. So 3 pi halves up, down 1. And then 3 halves plus 1 half is 4 halves, which is, so 2 pi, 0. And then 2 plus a half is 5 halves. And you can do it in your calculator. 5 pi halves up 1. And now, literally, guys, those are just x, y points you need to graph. Yep, so now we'll draw our new x, y point. You guys, I'm telling you, this is way easier than what we did last hour. So here we go. Our first one would be at over pi halves. And then 1. Isn't it still bouncing between 1 and negative 1? So I'll just go negative 1 and 1. So then pi halves, what would be next? Pi, what would be next? 3 pi halves, and then 2 pi, and then 5 pi halves. Okay, so this is just one cycle. So here we go. Then look, we already have the points. We don't even have to think. Over pi halves up 1. Over pi up 0. Over 3 pi halves down 1. Over 2 pi up 0. Over 5 pi halves up 1. You guys, we did not even have to think. Wasn't that dang easy? You guys have no idea how much easier that was than first and second hour for them. We did it differently. Let's not get into it. Let's do another one. Let's do another one. Well, yeah, I switch it up because that's what a good teacher does. If they see that it's not going well, they try something different. Okay, here we go. So let's list it out. Guys, come on, let's go quick. Our amplitude is 1. I need my period. My period is 2 pi over b. What's b? 1. And then we're shifting left pi fourths. True? Okay, awesome. So let's list out, once again, let's graph our original without the shift left and right. So if it was not shifted, we'd be our amplitude is 1 and -1. Over 1, 2, 3, 4 was at 2 pi again. Then pi, pi halves, and then 3 pi halves again. True? So then you would graph it. Still, sine is 0, max, 0, min, 0. So now list out those xy points, and then we'll perform the transformation. So over 0, 0, true? Over pi halves of 1, over pi of 0, over 3 pi halves, -1, true? And then over 2 pi, 0. And then we're shifting those left pi fourths. That's an x shift. So you'd go to your x values and subtract pi fourths to each of those. Here's my new xy points. 0 minus a fourth. Yep, negative pi fourths. Okay, we've taken care of that. And then still 0, right? This didn't change. Y didn't change. Then 1/2 minus a fourth. 1/2 minus a fourth. You would do it in your calculator. If you can't do that, that's fine. That's 1/4. So pi fourths, comma 1. Then 1 minus a fourth. You could do it in your calculator. 1 minus a fourth is actually 3 pi fourths, I believe. So 3 pi fourths, comma 0, correct? And then 3 halves minus 1/4. Do it in your calculator. 3 halves minus 1/4. You do it in your calculator. Math, enter, enter. I'm just making sure like that you guys can do it. So, okay. And then 2 minus 1/4 is, and that's at 0. This way is so much easier. I'm just so sad for the first and second hour. Okay, I'm going to have to send him a text to watch the video. Here we go. So look, it's still bouncing on y from 0 and -1 and 1. So we'll go like this. Up 1, -1. True? Then look, my first tick mark is at negative pi fourths, is it not? Yes? The next one is at pi fourths, guys. Then the next one is 3 pi fourths. The next one was 5 pi fourths. Look at the x-axis that we just listed out. Then it was 7 pi fourths. Isn't that only one cycle? Which is fine for right now. So now we'll literally just plot those points. Look, negative pi fourths of 0, true? Over pi fourths up, 1. Over 3 pi fourths up, 0. Over 5 pi fourths. And then over 7 pi fourths, 0. Sweet. Awesome. Let's do now both shifts. Both shifts, yes. Okay. Okay, here we go. Now we're getting into the where it's going to be 2 shifts. Let's go pretty quick here. So let's list out our amplitude again. So amplitude is 1, period, is 2 pi over b, which is 2 pi over 1. So that's 2 pi. Then we're shifting in words. Left, pi, down, 2. True? Now we're going to pretend, once again, there are no shifts. This is so much easier. Do not pretend that those aren't there. So let's draw this out over, so up 1, -1, over 1, 2, 3, 4 is at 2 pi, and so on. And then you'd say this is sine, so it's 0 max, 0 min, 0. 0 max, 0 min, 0, without shifts. And then we'd list out those xy points. So 0, 0, over pi halves up 1, over pi up 0, over 3 pi halves, -1, and then over 2 pi up 0. Is everybody good? So now in words, let's apply, now we've already done this. Left pi, so that's an x shift. So you go to your x's, and we're going to subtract pi, everybody, right? And then we're going down 2 units. So that would take all these y values and go subtract 2 from them all. Because that would take it down. Does that make sense, everybody? Okay. What are our, you guys are so distracting over there. What are our new xy points? 0 minus pi. Okay, good. 0 minus 2. Okay, awesome. We've just taken care of that. 1/2 minus 1 is negative a half, guys. So negative pi halves, and then 1 minus 2. Negative 1, that is true. 1 minus 1. 0. 0 minus 2 is negative 2. 3 halves minus 1. 3 halves minus 1 is, I believe, 1/2. And then negative 1 minus 2. Negative 3. 2 minus 1. And then 0 minus 2 is negative 2. Is everybody good? So now look, our xy axis here. I want to point something out. Look at your y's. Aren't they bouncing between negative 1, 2, and negative 3? So I'm going to go down negative 1, negative 2, negative 3. So list that out. Negative 1, negative 2, negative 3. So which one is the midline? Negative 2. So we could draw in our dotted line if we would like. And now we've got to put in our tick marks. So isn't the first one at negative pi? So back here, negative pi. And the next one's at negative pi halves. The next one is at 0. The next one's at pi halves. Oh, I'm doing them up here. Halves. The next one is at pi. So now you're literally just plotting points. So our first point is at negative pi down 2. Negative pi halves down 1. So right here. Oh my heck, I just feel so bad. I guess I can go back and reteach this lesson the first and second hour. Over 0 down 2. Over pi halves down 3. We're seeing the pattern, aren't we? Yeah. And then over pi down 2 units. And look, it takes care of the 0 max, 0 min, 0 for us. We don't even have to think. Everybody go. Wow. Please. Okay, do you want another example or no? Okay, let's just do this last one, and then the rest of the time will be yours. Here's why, because the period is different on this one. So let's look at this one real quick. So you'd say my amplitude is 2. My period is 2 pi divided by 2. So my period is actually pi, isn't it? And then it's shifted down 5. We're going to ignore that. We're going to just graph without the down 5. So our period is over 1, 2, 3, 4. That's actually pi, isn't it? On this one. You see? So then this one would be at pi halves. This would be at pi fourths. Then look, 1 pi fourths, 2 pi fourths. This is 3 pi fourths. True? And then we're going, our amplitude is up 2, down 2. So then let's graph this. We do need to remember the pattern for sine. 0 max, 0 min, 0. True? So right here. 0 max, 0 min, 0. So now we could list out, we're going to list out those original xy points. So 0, 0 over pi, 0, 0 over pi fourths up. 2 over pi halves up. 0 over 3 pi fourths up. Down 2. And then over pi 0. And now we're shifting those down 5 units. So isn't that a y shift, everyone? So you'd subtract 5 from all of those. So our new xy points, x did not change in this one, so we'll still have a 0. 0, and then minus 5, true? Pi 4 still, and then negative 3. Pi halves, negative 5. 3 pi fourths. Negative, nope, negative 5 minus 2. And then over pi down 5. So now look at your y-axis. It's bouncing between negative 3, negative 5, negative 7. So down 1, 2, 3, negative 3, negative 4, negative 5, negative 6, negative 7. So what's the midline? -5. Then our x-axis is starting at 0 still. Pi fourths, pi halves, 3 pi fourths, and then pi, and then we would just plot points. Over 0, down 5. Boom. Over pi fourths, down 3. Over pi halves, down 5. Over 3 pi fourths, down to -7. And then over pi, down 5.
So with the y-shift, that you just like plotted normal.
Yeah, but this one we lucked out and didn't have a shift left and right as well. This is just the easiest way with once we get into complicated shifts. Okay. Honestly, guys, you guys, that went so smoothly compared to first and second hour. So I'm happy. I think you guys can finish the lesson. So ready to go. Finish at 5 through 10. There's a typo. There's a typo on 9. Let me show you what 9 should be. That's number 9. Notice it's missing the X. Let's see if you can get done.